All right, back in business. Cool. So we all know that JavaScript is single-threaded. So it starts its execution from the very top of the JavaScript file and just continues all the way down that file to do whatever it is you want it to do, whether that's console logging, making modals, executing events, so on and so forth. But then there's also the concept of asynchronous I guess, asynchronous JavaScript, which you guys have looked into on the front end side. And I kind of want to get a few examples from the class on where you guys have used asynchronous features of JavaScript to kind of, one, facilitate the work that you want to do on the front end so that there's not blocking code on the back end. So you want to throw out a few examples of where you've seen asynchronous JavaScript. Ajax calls, event listeners, those are all perfect examples of where you guys are using libraries to help do work in the background. So let's see. Let me show you a quick example of what I mean. Let's see. Well, there's not a really good example I can give you, but so for example, let's say you guys need to make a call to like the IMDb API that you guys are probably pretty familiar with. Sometimes that request can take a long time. So on your web page, let's say on page load, you need to make a request to IMDb, but you don't want the page just to sit stalling, waiting for the page to load. So maybe there's other JavaScript, maybe there's other HTML elements you want to render first. So your page could load HTML elements with the CSS along with JavaScript to make sure that the page loads in general, but you might have an empty table sitting on the front end, waiting for that AJAX call to go make a request to IMDb. Once that's successful, come back and then populate the table on your front end. That kind of improves the user experience versus just seeing a blank page, waiting for all of your elements to finally do what it has to do. That's just a simple example of where asynchronous development can help improve the user experience on your web page. You guys understand that example? Cool. So we're going to do a little bit of a review today on callbacks within JavaScript, and we've seen this example of callbacks in previous stuff, like for example the file system example. Let's go over there to read file. This function over here that we're passing in that handles the error and the data within a file is called a callback function. It's a function that gets executed after the file has been accessed. So this happens asynchronously. What doesn't happen is that when this file is being executed, it starts at the top, it defines this variable, but it doesn't block over here saying, okay, I'm going to wait until this file is read, print out the information, and then continue execution. It's just going to continue. So if I do a console log over here, finished, you're going to see this log before the file ever gets read and then prints to the page, because this is happening in the background, in a background thread. So let me navigate to that exercise. This is exercise 05. And once again, this isn't stuff that is brand new. This is all stuff that we should have already seen before on the front end, where, oops, did I save this? I'm in the right place. Okay, cool. You're going to see the finished printed first because the execution flow didn't block on file system read file. It continued down, ended, and then in the background, when that background thread went to read the data.csv got completed, it then console logged that information out to the terminal. So just a review, refreshing you on what callback is. So when we take a look at this exercise and see what this exercise is asking us to do, it says we're going to read a file called animal.json. And that animal.json file is an array with a bunch of JavaScript objects that have cats in it and dogs in it. And we're going to iterate through that file by reading through it. We're going to take that data object that we get back. We're going to parse it using the JSON parse function. Now we're going to have pretty much an array of animals. We're going to iterate through this array of animals and drop them into their specific arrays. So we're going to push dogs into dogs arrays, push cats into cats arrays. And then for this activity, it's going to ask you to create individual dog.json files, a file, and a cats.json file. So when I navigate to the solved section, This is what happens on execution. We're now going to have two new files called cats.json and dogs.json. And when you view those files, cats, of course, .json is only going to have cats, and dogs.json is only going to have dogs. So I want you guys to get into the habit of breaking out the work. So we know, actually I'll just type it out in here since people might be live streaming. The very first thing we do is loop through animal JSON and add the cats/dogs to their specific arrays. Once you have those arrays populated, you then would have to do, well, what function would you use to create a file? What did we learn about on Monday's class? Write file. We know we have access to the file system library at the top. We know that we're using read file function to read the file. So now we would write the file, write cats slash dogs to new files using the functions that we've played around with in the past. So just ways of kind of breaking up the work. You want to get into a habit of when you have exercises or projects, creating like a step-by-step list of things that you know you need to knock out so that it doesn't seem like one large problem that needs to be solved. There's individual pieces that you can do to get to the final product. So let's do this for 10 minutes until, yeah, let's do this until like 10:20, and then we'll move on. So that will be exercise 31, and I'll select out the instructions. And just a reminder, the exercises can be found in the general Slack channel if you haven't downloaded it yet. If you need a refresher on how the syntax for writing a file looks, you could always go to the official documentation for file system in Node.js to see how that's done, or you can refer to exercise 6, where you have examples of writing to files. For those walking in, we're looking at exercise 31, callback reviews. All right, 2 more minutes, and then we'll take a look at the solution. Okay, so now that you guys are done working on that, let's take a look at the solution on this particular exercise. So, um, as we saw earlier, we broke this up into two specific points that they wanted us to do. We needed to loop through the animal.json, and then using conditionals, confirm within the objects whether it's a cat or a dog, and then add them to their respective arrays. Once we're done with that, then we'll add those individual arrays to a new file called cats.json and dogs.json. This is what that loop would look like. It would be animal.json for each, where each element would be an animal, and then we're just checking that the species is equal to dog, and if it is, we're pushing it to that array. This is pretty straightforward. The next would then be JSON stringifying the arrays that we create, so that we can then add them to the files that we want to add them to. So now we would have the dogs array in a JSON string and a cats array in a JSON string, and then we would create file write functions for those individual files, and then just write that JSON stringified object to the file, and then console log if it's successful. So there's two individual write file functions. Any questions on this solution? Yes. So let's take a look at what those options are, because I actually don't know off the top of my head. So if we go to JSON stringify, because you shouldn't need them. Yeah. Let's see, it's a replacer and a space. Space is that inserts a white space into the output of the JSON, so that's just styling. And then a replacer is alters behavior of stringification process or on the array of objects and serves to whitelist. Is for filtering and parsing out information. So if you wanted to filter, you have that option, but as you can see, they pass a null. It's not necessary, and this is a quick exercise. I don't care about styling, so you don't need the null or the two. You could just do JSON stringify dogs, and you get exactly the same behavior. So questions on this solution? All right. I got to keep speeding along because we got a lot of things to talk about today. You guys are very familiar with Ajax. You guys use Ajax a lot in your previous projects and exercises. Node.js's version of Ajax is called Axios. And I will slack out that. So let's look on npm Axios. Click on this. And then I will slack this for you for documentation purposes. It allows you to be able to make requests out to to other URLs asynchronously, so that your node server is installed. So for example, when you guys looked at the previous solution, I want you guys to pay attention that this for loop over here is a synchronous for loop. So this blocks the code. It will wait until that loop has gone through and searched all the different animals and then added them to the individual arrays. But then when you finally get down to writing the files, these are asynchronous functions. This will not block your code. It will continue execution and move on to the next line while it builds that file in the background. The same way we want to have that same behavior with making requests to URLs. Axios gives us that ability to make a call out to OMDB API without blocking my code, so I can continue and do for loops over here or other console logging while waiting for this information to come back. When it does come back, we then pass it through to a then function, and that then function has a callback function, which you can then execute whatever application logic you want to do with that returned request. So just to show this in real time, let's go to exercise 32. npm install. Why are we npm installing it? One, to be able to use it, and two, what else? One key indicator for when you know you'll need to npm install something is that it's a third-party library. It does not come by default with Node.js. So you guys are using code somebody else built to help facilitate the work that you want to do. So when we take a look at the package.json, you'll see that it has dependency. Axios, we're using version 0.19. And package.json is usually also an indicator that there may be dependencies that you need to npm install. So we'll npm install it, get that in there. We'll now have our node modules exist, including that dependency. Then we'll execute the index.js, and you'll see that now it's pulled out the information that I wanted, which is, what were they asking us to do? Yep, it was looking for the Matrix movie. And we can console log at the bottom, finished. Just to kind of cement the point that this is happening in the background. So finish will print first because that's the end of the application's execution lifecycle. And this request, which is happening in the background, it can take 5 seconds, it can take 10 seconds, it can take a whole hour. We don't care. Our application will keep waiting until that's executed and then print it out to the screen based on the callback that we have in this then function over here. Questions? Yes, you need to always initiate npm install because when you execute this file, so for example, let me remove my node modules. If it doesn't already exist, if I try to execute it, it's going to tell me cannot find module Axios. I mean, your code is just not going to work unless it has the dependencies it needs to do the work it needs to do. npm install isn't working for you? No, just npm install. The reason we're not doing npm install Axios is because our package.json already has it defined. So it's kind of like a shortcut. So when you are playing with somebody's code and they have the package.json, they're going to list all the dependencies they need for that application to work. So you could go to this package.json and say, okay, I see I need Axios, and you can manually type out npm install Axios. That's fine. But to save you time, you can just do npm install, and it will install all the dependencies listed in the package.json. I can circle back in a second. Does at least the concept of Axios and the way it's familiar with, it's similar to Ajax getting and Ajax posting. Does that make sense? This already exists for you for our exercise purposes. But if you're creating a new project, you would have to create the package.json. And who remembers the command for that? npm init, that's what creates the package.json for you, and then you would do npm install Axios, and that would save it to your package.json. All right, so just kind of reinforce this new concept, we're going to do a real quick exercise on Axios. That would be exercise 33. We'll do this for 10 minutes. Exercise 33. And let's take a look at what they want us to do. In the unsolved section, you're going to have a package.json. This is going to show you that you're going to need Axios and you're going to need an inquirer. You'll want to npm install that. Then they've already done the inquirer work for you, where they're prompting you for your GitHub username, and then they're making a call out to GitHub's API with your username and listing the different repos that you have. What's being asked for you in this exercise is to take that list of repos and then create a repo file called repos.txt. And you're just going to list all the different repos for that GitHub username that you passed in on the prompt. So, to show you that in action, exercise 33. Whoops. I am in the wrong section now. Where did I go? Alright, my file system seems to be messed up. Let's open this. Wrong location. Alright, well, I won't demo that just yet. I'll get myself situated. But start working on the exercise and realize that all you need to add to this function would be the file system commands to write the repos to a brand new file called repos.txt. So we'll do this for 10 minutes, and then we'll look at the solution. I'll figure myself out. All right. Okay, now that I'm back to where I need to be, just to show you what this looks like, I'm going to execute it on the screen. Node index.js is going to ask me for a GitHub username. That would be cave. I press enter. It's going to say saved 70 repos. It's made that execution out to GitHub, to the GitHub's API. You'll see that already provided for you in the unsolved section. Is going to make a call out there. But you guys are going to use Axios to make that call out to that query URL. And then it's going to print out all of my repos to a repos.txt. And those are all of my repos. So that's what we expect to have at the end of this exercise. And always remember to break up the exercise into sections. First, make sure that you're executing that call with Axios and you get the information that you need successfully. Then worry about writing that to a file. So just break it up. For those just joining us, we're working on exercise 33. So,
How does remote attendance work again? What software are you using?
remote attendance? That's okay.
I mean, not remote, like live stream.
Oh, yes. So that's just running in the background. I'm using this app called OBS, and that's just streaming directly to my YouTube link that I posted earlier.
On what?
YouTube.
Okay. Did you send it to them in the Slack? Okay, then I'll try it.
Yeah, I can resend it again.
Yes, please.
3 more minutes, and then we'll take a look at the solution. Okay, let's take a look at the solution for this exercise. The very first thing we want to do is make that Axios call because we already have the query URL and we have the GitHub username that we want to query for. So then we use the Axios.get function, providing the query URL, and then that information is then passed into a callback function where we work on the response returned from that URL. From that response, you can console log out the object and see what information is passed back. So like console log res. You then can get a better idea of the object that you need to play around with. is going to be huge. See, so it's going to pass back a huge object. Let's go all the way to the top. Oh, scroll a little too far. There we go. Where it has keys like status. It was a 200 status, so the request went through successfully. Status okay, okay. We have headers, and then we have configuration, and then the actual request object itself, along with the responses. So we're going to pretty much have to parse through this information to try and get to the data that we actually care about, and that data exists in a key called data. That data is an array with all the individual information, with all the individual repo information that I care about for this topic at hand. So what we're then going to do is take that response, grab information from the data key, and then use the map function to retrieve the repo name. You didn't have to use a map function. That's a shortcut. You could have just looped through the entire data object and pulled out that key that you needed, which would have been the name over here. But there's multiple different ways to tackle this solution. So we're using map in this particular scenario to grab the repo name, throwing it into this array called repo names. We are then going to use the file system object to use write file function to create a file called repos.txt, and we're just going to write all of the individual repo names into this new file. This is also another shortcut over here where they're taking that array using a join function and adding a new line to strings for each of the individual names. That's why when you take a look at the repo.txt, it's the name of your repo along with a new line, and then the next repo, and so on and so forth. So if you're not familiar with the join function, definitely Google it. Get familiar with what that's used for. That's what online documentation is for. But we are quickly going to move on to something called promises, which I believe Lawrence is going to talk to us about. The reason we're introducing promises is because callbacks is ES5 syntax, promises is ES6, and then eventually we'll talk about async and await, which is ES7. So these are all kind of new ways to do the same thing, except now they're more readable and hopefully more user-friendly for the developer. The reason promises were introduced is because you can end up in situations like this where, in this particular scenario, let me make this bigger, we are reaching out to a database, so it's going to be asynchronous so it doesn't block our code. And we're verifying the user, and then we have to make sure we're handling errors and then doing stuff with the data. Then we move on to getting roles for that user and handling errors and using the data for something else, and then logging that database access, handling errors, and doing more application logic. And this type of interaction continues to expand, that you could have a very, very unreadable code as it moves to the right of the screen. So to kind of make application logic more readable, promises were introduced, and Lawrence will get into that a little bit further. So give us 2 minutes to get situated, and we'll talk about promises. All right. So I used blind text, so you'll find all the different exercises over here. And then typically I'll have the lesson plan over here on this computer, and I'll just scroll through that. The terminal appears, you can navigate to the different exercises.
We have a blue spectacle on here, and
What's that?
it's like for like Windows when I'm looking at.
Yeah.
Yeah.
Probably should get that.
But I think it's this though.
Okay.
Okay.
Cool. Scroll to the bottom.
Yes.
All right.
All right. Cool.
All yours.
Thank you. Okay, so hey guys, it's nice to be up here. I'm going to be introducing promises. Already got a little bit of background from Manuel, but promises are essentially JavaScript objects that can be used to control the flow of asynchronous code, and they function pretty similarly to promises in real life. They're either kept or broken, and we're going to get into how they function and work as we look into the code. But I have a couple of questions for you guys before going into that, which is we have used promises in the past and in the recent past, and does anyone know where we use them? So anyone? we technically used promises when we were using the Axios call and also in Ajax. When you see that when we're using the Axios call, we're getting information back and then we're executing after that information is returned. And when we use that word "then" in the Axios call, we're executing a promise. We're basically saying when this happens, when this line of code is finished, execute on it, and it's setting up a condition. And that's sort of what a promise does. It says when something finishes, start a new functionality. Another question: how are promises visually different than asynchronous callbacks? Does anyone know that off the top of their head? So promises, as I was saying before, use a .then method to describe what should happen once the async code completes. And we can actually see that here in the code pulled up on line 29. That .then, as you saw in the Axios call, exists here, representing a promise-based function on line 29. Okay, cool. So moving into our promises introduction, we have some code written out here. A couple points to bring to light. There in the Node library, we have a functionality called util. It's a module that allows us to use utility functions. One of them is called promisify, and that can convert functions that we've used before, like fs read file from the fs library, into a promise-based function. And so, as it says here in the code, the built-in util package can be used to create promise-based versions of functions using node-style callbacks. So we include util here on line 2, and then we call it down here on line 5, and we use this promisify method to pull back to convert fs read file into a promise-based version of what it was before, which we have used before when in our earlier example of callbacks. So similarly, in this exercise, we are parsing the string of animals.json into an object. We have our two arrays that we're passing dogs and cats names into, like we were doing before. The main difference happens down here, where we turn the array into JSON strings so they can be written to files. As you can see at line 29 and line 33, we have two new functions, write file async and write file async, and they're doing the same thing, one for dogs and one for cats, but they both are using a promise, which is once the file is written, then we're going to have a console log message that tells us that we successfully wrote to dogs.json file and cats.json file. So let's see that run in real time. Let me pull down. So I just ran node index.js, and you can see that the callbacks were working properly, and we received these console log messages: successfully wrote to dogs.json file, successfully wrote to cats.json file, and we can see those two files pulled up here. So just going through some overview there, promises are a cleaner way to execute what we've already been working on in callbacks. and they were introduced, as Emmanuel was saying, in ES6. So currently, do we see any benefit to using promises over callbacks yet? Yeah, that's great. That's great. They're cleaner. They're cleaner to write out. Another benefit that we've already brought to light a little bit is that we can avoid nesting, like we use with callbacks. Promises are written linearly, so you don't have what they call as like callback hell, which was that image that was shown before. uh, it's a good question. I don't know. I think that at this point, you use promises. Yeah. Yeah. Yeah, and we'll see most of the ways that we're using, like what most of the ways we're putting promises to use, we are converting callbacks into promises. Like we're doing it here, and then we will further observe that using the promise constructor. Cool. So moving on, we're going to open up on, if you all have 35 STU joke saver, pull up the instructions. Oh, okay, got it. Um, yeah, so in this activity, you will write code to get a random joke from an API, append the joke to a file, and then read out all saved jokes from the file. So, yeah, going through these instructions, we're going to be changing directories into the unsolved folder and running the npm install. Once the installation completes, open unsolved index.js and examine the code. A request is being made to the icon as a joke API using Axios. So we're going to be using Axios like we learned earlier to pull back our jokes. This API requires some additional configuration to be passed to Axios in order to work. And then we're going to run the index.js file to examine the response from the API. You should notice an object containing a random joke is returned each time. And then, yeah, following through on the instructions and letting us know if you need any help building this out, we're all available for that. And then we'll walk through it in 10 minutes. So good luck. All right. Moving on to the solution. Was anyone able to solve this and kind of flow through the method of starting to build out the joke generator with callbacks and then moving on to promises? Oh, okay, cool. That's awesome. How was that? How was that experience? What strategy did you utilize? No, I think it's a good point. When you end up nesting and using more and more functionality, it becomes really useful just as far as syntax and order goes. But to your point, the function is going to be similar between the two. Yeah. So I think that that's a very valid, yeah, point. But also it's good if we can have something that's more readable and more clean. It's always better to use that over something that's going to be confusing since we're sharing so much of our code with other people. Um, yeah. So turning to the solution. So one thing that we should pay attention to here is on line 15. We can see that there is there's a number of promises starting on line 12, but line 15 and line 16 we have a promise and then a second promise style function nested within it, and it's important to pay attention to that because by nesting promises we can control the order in which they resolve. Um, the We also are putting to use the util permissify method. So like we were doing with the write files in the last example, we're using util permissify to permissify the append file and read file methods from the FS library. Um, we Also need, so we'll need to use the fs append file, which we were just looking at there, method to append text to a text file, and keeping in mind that each line should be separated by a new line character, which is represented by \n. And that's just to say that we're appending the various jokes that we return from our Axios call to a text file, and then we're able to view those when we call back the index file in our terminal. So top of the page, we use the util permissify to create promise-based versions of read file and append file, as I was saying before, and then what we're doing here is we're appending the joke retrieved from the API file to the jokes text file with new line at the end instead of the then of the append sync file function, we're calling read file async to read the file's contents. Since both functions run asynchronously, this is how we can ensure that the file isn't read before it's written to. And that comes into play with what we were talking about at the top of the page, which is that when we nest functions, we can control the order that they return in, which is important, especially when we want to do something like this, where we are controlling how the dad jokes are appended to each other on the page, on the text file. Before running this, what are the advantages of using promises over callbacks in this example? We were talking about that a little bit, but can we think of any other ones beyond syntactical that would be advantageous to use promises over callbacks in this example? The answer to that is that there isn't one. So, it's more orderly, it's best practice, but in this particular example, there isn't an advantage. And yeah. um, in the in yeah. Sure. All right, cool. Yeah. And then going back, so yeah, so I think that the most important takeaways from this example are that then is chainable, so we can compile as many linear promise functions one after the other using then as a chain, and I think that that's the great point too that we can catch errors in a global way at the end of our call, and um, and now I think the one thing I wanted to slack out to is there's to reinforce what callback hell looks like. There's an image provided. So let me just post that in the general Slack, um, showing that. And this image is just to reinforce that if promises didn't exist and we only had callback functions, we'd eventually find ourselves in callback hell, where our code nesting becomes so deep it's difficult to understand, and we have to scroll horizontally in our editors to read everything. And so now, yes, yeah. No, so we are taking our joke and appending it to a text file, and then when we run node-index.js, we will read that file and see what we've appended return. Yeah, appending is like adding the line, like the string to the file. The file is jokes.txt. So when we, yeah, so running that. Yeah. Let's see. Let's start this over. Yeah, I was just trying to note it. I have the npm installed all the packages in, I think both, but yeah. Okay. Yeah, rerun. Old laptop, I guess, is finally beginning to crap out. Is there any way I can hook this? If you have an HDMI port. I don't have the adapter, unfortunately. Gotcha. Oh, this has I forgot the old school MacBooks have that built-in. That's great. Yeah, it's like a 2014. Alright, so okay, then npm install. Yeah, so alright. Okay. There's another function. I know what this is. Gotta make sure you guys are using the correct node version. So now that we're in node that, okay. Cool. Okay, cool. But yeah, so as you can see, when we run node-index.js, it takes a joke and appends it to that list of jokes in the jokes.txt file. It's the right. Right. So the jokes.txt file isn't like in the file path. It's being created. Yeah. It creates it. It auto creates it. Right. So like sort of to what we were saying. Yeah. The file is right here. I think Emmanuel is going to help you find the file. All right, cool. All right, guys. The last thing that I'm going to bring up today will be the promise constructor. So up till now, we've been using the promisify command from the util library, and that's how we've been converting our pre-existing functions into promise-based functions. With the promise constructor in ES6, we can actually build our promises without even using that library command. And we're going to be walking through what that looks like. So promise objects can be constructed from scratch using a JavaScript function. ES6 introduced native promises to JavaScript. Before this, promises were still used, but the functionality was provided by various third-party libraries. And we saw the use of a library to build promise-based functions in our last couple of examples with util promisify. Now that promises are built into JavaScript, we can more easily use promises to wrap any asynchronous behavior. The built-in promise constructor can be used to convert a call-based function into one using promises similar to what util promisify can do for some types of functions. So diving into the actual code, as you can see here, we're not requiring util from the library anymore. We are interacting with this function called readFile async, and inside of that function, we are returning a new, and then the keyword here being promise function. And so on line 4, that's where we introduce what we know of as the promise constructor. We're using the promise constructor to create a readFile async function, essentially doing what util promisify already was doing for us. Promise is a special type of function known as a constructor function, and we'll be discussing constructor functions in depth in our next unit. But for now, students, we need to call this function using the new keyword, which we're doing here on line 4. And then it will be returning a new promise object. So we are doing, once again, we're doing what we were doing before, but we're using this promise constructor to convert our read file function into a promise-based function. And that can become really useful, especially too when we're using custom functions and we want them to follow that promise-based syntax. So the promise function takes one parameter, a callback function. We have that here at line 5, fs read file. And the callback function function passed to promise has two parameters of its own, resolve and reject function. So we see those two parameters here, resolve and reject. And then the resolve function is called when we're done with our async functionality if nothing went wrong. So the resolve function can be provided arguments which will be available inside of the then of the resolved promise. The reject function is called if something went wrong, such as an error occurring. Anything provided as an argument to reject is available inside of the catch of the rejected promise, which we see down here, where like Emmanuel pointed out, we have a catch method here that's called on our read file async function that we're defining up here, and that is going to be the global catch for errors in the future when we're running our functions. And so setting up our read file function, since the read file async returns a promise object, we can execute read file async and then use then or catch from its return value. So just breaking that down into plain English, we create our function on line 3. We return our function. Within our function, we define it as a promise-based function. And then when we actually are executing the function, we can use promises like this then to execute the function linearly. And in this particular case, have our data show up in the console log or have an error message show up in the console log if the promise is rejected. So moving in, let's before we move on to an activity, let's run this promise. So our example text was meant to read hello world. When we run the function, hello world appears in the console log, so it looks like the function's running properly, and we can see that when example text is passed into our function, the data is console logged, and there was no errors. So that's a very simplified method of how to use a promise constructor to create a promise-based function. But I think it's important to remember that this is just building off what we knew before with Promisify. Any questions before moving into our activity? The promise constructor. Oh, you can use the promise constructor at any point whenever you want to apply promises to your code. But yeah, great question. Great, so let me just shift into the activity. All right. Awesome. So in this activity, we will refactor a callback-based asynchronous function to utilize promises. So similar to what we were doing in the last activity, we're taking a function that's based on callbacks, and we're converting it to utilize promises. I think following a similar flow to what we had in the last assignment would be a good strategy for solving this. And so read through the instructions on the summit and let us know if you need any help. But it's a fairly straightforward action of taking something that is already working and existing and converting it into a promise-based function. All right. So, was anyone able to solve this one? Get it written out. All right, cool. Well, we can go through and review it. So, taking a look at our promise constructor, I think that one of the key takeaways is what is happening on resolve and what is happening on reject. Um, in this particular case, we are timing. So we are timing this function to resolve if the function is working properly, resolve on success. But if seconds, which is listed up here on line 3, is not a number or isn't a number or is less than 1, then we're going to have an error message. Parameter seconds must be a positive number. So we have a condition set up here, and then we are running our function, and we are expecting a return of our success message if the function meets the conditions, and we're expecting a return of an error message if the function doesn't. So let's give that a shot. Starting out, when we run, let me just make sure I'm in here. So we can see that the function ran, and we received a success message, and then we can also just like see that, yeah. So we can pass into, for example, we could define seconds up here. As a string, and run it again. And we can see that our error message, seconds must be a positive number, appeared under that parameter when we pass in a string. So just watching the key functionality here being that we can control what happens on success, and we can also control what error messages are returned if the promise is rejected. And this is also, a working and good example of seeing us use the promise constructor here to build out a promise-based function, and then see us use promise-based components like then and catch once that function is constructed. So yeah, before moving on to introduce async and await, are there any questions on Promisify, the promise constructor, the use of promises in general, versus callbacks? Great. I will pass it off to Sabrina for async await. You have it set up over here?
Yeah.
All right, cool. Awesome.
Yeah. Okay guys, so now we're going to talk about async and await, which is essentially sugar syntax for promises. So what do I mean by sugar syntax? Anything that makes something complicated appear simple. So promises are sugar syntax for callback held, right? So all that deep nesting promises just makes everything cleaner. Async await makes promises a little cleaner. So now we're just cleaning up everything to minimize the amount of code we have to write up, to make it easier to understand when we read it, okay? So let me first show you what async await looks like. So let's say I have a variable, I don't know, let's call it is happy, okay? Is equal to await my promise. Async and await only works if you are using it in a function which starts with async. Oh wait, I just realized I'm not using a JavaScript file. Give me a second. Yeah. All right. If you have async function, my async await function. Okay, it's just a random function like that. Yeah. What is happening here? This is what async await looks like. So let me just explain it. You start with the async keyword before the function, and then inside you await a promise. So what does it mean to await a promise? So Lawrence just talked about promises, right? We're waiting for the result of the promise. Async JavaScript means that something is about to take longer. It's not about to run in a single line like we're used to. Okay, when we have 3 console.logs, it's going to go console.log1, console.log2, console.log3. When you're dealing with async JavaScript, something is going to take longer. Okay, and that's what we need to await it. Okay, so this is a little bit like saying .then, but it's a better way of saying .then because you know how to read this easier than .then. Okay. So I'm just going to open one of the examples provided, and we're going to talk about that. So that's exercise 38. You can open it. All right. So in the first 2 lines, we're getting our modules. We're getting axios or axios. whatever it's called. We're getting our inquirer, and then we're calling this getMovie function, okay? As you can see, the getMovie is an async function. Because the await keyword right here, it will only work if you're using an async function. So you can't do this whole concept thingy if you're not using an async function. That's the most important thing for now, okay? So here, I'm highlighting something. So const movie, that's our object destructuring, which we talked about last class. So we're just getting the movie property of the object that will be returned. We're storing that in our const, which we're calling movie. And here we're awaiting something. So we used the inquirer before, and it's a promise. Because first you'll put the prompt, and then you'll put the dot then, and then you'll put the catch. So we know that we're dealing with the promise. The only thing we can await is a promise, okay? So here we're awaiting the response. He just talked about how promises can reject or resolve, right? So whenever the promise will resolve something, that's what we're saving. That's what we're awaiting, okay? So anytime you see await, it means you're awaiting that thing that the promise will return. So we're awaiting it, and then we're saving it in this variable, in this const that we call movie. And then we're logging the movie. And then we're doing the same thing here. We're awaiting the result of our Axios get, and whatever data will be passed, we're saving it in the const data, and then we're logging it. And then at the end, we catch the error. So here, we're using a try and catch block, like we did for the promises earlier. We have to do that with async await, so we can capture all our errors in one catch and then try everything at the same time. So that's just our error handling system. But do you guys understand how async await works a little bit? Or is it pretty clear? Like, do you have any questions? Not really? Okay. So it's just to say that if we were doing regular promises, where you see the await, you wouldn't have an await. You would just have inquirer.com, .then, .catch. But the async await just makes the whole thing shorter, because now we're just saying await inquirer.com. So whatever inquirer.prompt has to do, if it's fetching, if it's handling, whatever it has to do, we're just waiting for it. And then we're saving it in our variable. That's it. Okay? So you don't need to use a bunch of .thens, just like we don't need to use a bunch of callbacks. Okay? So this just makes it easier. And another thing that's important to note is that promises are async JavaScript. So what happens in our regular code is that if we have a promise and it's taking too long, it'll just go to the next code, right? The next piece, the next line, because the promises are operating in their own async thread. With async await though, it's literally gonna wait. So it won't log anything until this is done, which is perfect because that's what promises do in the first place. This is what I'm saying, it's replacing the .then, but better, because we just read it better. You get it? So it's gonna await and then log, and then it's gonna await this and then log, and then it's over. Exactly. So it's essentially replacing .then, 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 you know? Just like callbacks are replacing callback hell. So this is replacing .then, like endless .thens. Even though those are pretty easy to read, this is just even better, okay? Yes. So yeah, exactly that. So I can't say, let's say I want to do something else. Let's say I define some code here that doesn't exist yet, but let's say this is my promise. Let's say I created a promise here, okay? And then I want to say, oh, let me await this promise. Let me run this promise. And I just want to save it here. And I'll say const promise results is equal to await my promise. Okay. Assuming I created a promise. Okay. This won't work. It won't work because I can only use the await keyword inside of an async function. That's it. Okay? That's the only catch. Alrighty, so now we're going to try exercise 39. Mm-hmm. Mm-hmm. Alrighty. Yeah, so try exercise 39 for 15 minutes. It says, in this activity, you will convert a previous promise-based activity to utilize async await. So what we've been doing with callbacks and then what we did with promises, we're going to do the same thing, but we'll convert everything to use async await. All right? Take a look at that. Mm-hmm. Actually, I didn't check what time we started. Do you remember?
Yeah. So what we got here, 12, 10.
Okay.
Then we talk about 3 to
12:30.
20.
20.
Then we 30 minute break.
Okay.
So 12, 20, then we just break.
Okay. Alrighty guys, we're going to talk about the solution to this exercise. I'm going to open the solution. Okay, but first of all, who understood what was going on here? Who thinks they got it? Somehow, a little bit. Well, at least you tried. That's fine. Okay, so this is what the solution looks like, and I'm quickly going to explain what's happening here. So in the first two lines, we are taking our modules and saving them in variables, okay? We've always done that. On line 6 and 7, we're doing what we did with Lawrence's exercise. We're promisifying functions which weren't promises. So we're making them promises. And why does this matter? It matters because you can't use an await. You can't use async await with anything that's not a promise, okay? That's why you have to make it a promise if you're trying to await it, okay? Got that? Okay. So now we have our async function, which they already made for you, actually. And then the function is called at the end. So what's happening inside? I'll just talk about the error real quick, and we can talk about what's happening in the main block. So in the catch, we're just catching our error as usual. And in our try block, this is where all the interesting stuff is happening. So we are interested, we want to get the results of this file called hamster.json. So whatever is in here, we want to save it. Oops, where did I put it? Yeah, whatever's in here, we want to save it. Close my, hold on, sorry. Yeah. So we're reading our hamster.json, and we're saving the results in the hamster variable. But we're reading it in a very different way than we are used to. So we're reading it using the await keyword. And remember, it only works because we declared that our function should be an async function, okay? Don't forget that part. So we're awaiting these results, and we're saving them in hamster. Then we await the results for this file, which is dog.json, and we save it in the dog variable. Then we await the result from the cat.json file, and then we save it in the cat variable. And same thing for the goldfish. So one by one, we're saving everything one by one. And just to emphasize, the read file.async, all of these functions, they're all promises. How do I know they're promises? Because we made them promises right here. The original function uses a callback. But if you want to await it in this way, you have to use a promise. Okay? And why would you want to do this over regular code? Can anybody tell me why we would want to write this way instead of using the original function the way it really looks like? Yeah, short syntax, obviously. Because if we didn't have that, we would have the fs.read file, open, put the file name, comma, function, too much work when we can just do this, okay? Now here is another interesting piece of code. We have the constant animal JSON, which is our variable, and we are mapping. Okay, so we quickly put everything in an array, so we could use a map method. We're mapping everything to json.parse. So this means that, just like we talked about last class, we're going through the array, we're taking hamster, putting it in json.parse. Taking dog, put it in json.parse. Doing the same thing for cat and doing the same thing for goldfish. And the map is going to return, because it returns something, right? It's going to return an array with everything that happened here. So if you put a regular callback here, it's going to do whatever you tell it to happen and then save all the results in an array. Here, what we told it to do is to parse it for us. So it's going to parse them one by one. And then our results will be an array, everything parsed, and that's what we're saving in animal.json. Okay? So animal.json is actually an array of all of these things parsed in JSON. And then our last thing is to write it to the combined JSON file. So we're also going to await here because our write file is also a promise. That's what we're using it. So we await the write file async, combine JSON, and then we string the file. We're writing it to this file, and then this is what we're writing. We're writing what we have here, which is an array, but in text and regularly in a string. So we string the file. We talked earlier, I think Amanda talked earlier about what this is. This is not necessary. This is just if you want to format it a specific way, and this is just if you're trying to do some filtering, which we don't format right now. So you can just ignore this part. But yeah, this is what it looks like, and then at the end you just constant. And remember, this won't happen until all your weights are completed. It's not going to be like regular JavaScript where you skip and then it'll come back now. And wait. Okay? And that's that. And you guys are on break.
This class, but definitely run the course of reading the Laura's and class that you do at 12.
In order to have enough time to get ready.
Stop.